I'm Saji Chako. I'm going to explain you about distribution transformer. But the function of the distribution transformer is to feed the industrial and the domestic loads. So this transformer is basically, because it's a college transformer, so our college is considered as an industrial load. So I'm going to tell you about the different parts of a distribution transformer. So first you come to the ST side of the distribution transformer, that is the high voltage side. So when you stand in front of the ST side of the transformer, your left hand indicates the R phase, and normally the R phase, then comes your Y phase, and your right hand, your position of your right hand indicates the D phase. So the same way on the LT side, you can see that on the LT side, you can see that you will have this one indicates your neutral, and then the R phase, and then the Y phase, and then the B phase. You can see that the 2N stands for the neutral on the LT side, the 2U1 stands for the R phase, the 2V1 stands for the Y phase, and 2W1 stands for the B phase. This is the box, the LT gland box on the transformer, from where we, through the cables, we take it to the panel. These cables are of 150 mm square mm size or 180 mm square size as per the requirement, and then it goes to your load, the panel or the LT panel placed in the panel board. Fine. Now again coming back to your ST side, you see that these are the cables, the overhead wires are directly terminated to this bushing, which is known as the ST bushing, and you can see that there are two rods, and these rods are known as the arcing rods. And the function of this rod is to protect the transformer from any surge, whether it's a lighting surge or a switching surge. Mainly it is for the lightning surge. Fine. Now, the most important thing when you come to the transformer is seeing the specification sheet or the specification details of the transformer. So now, with this transformer, you can see that it is made by Crompton Greaves, and you can see that the rating of this transformer is 500 kVA, and the HV rating is 33 kV, and the LT rating you can see it is 415 kV. For 40 plus minus, the deviation is given, that means plus 10% it can go or minus 15% it can go down. And the type of cooling is O9, that is oil natural and air natural, and for a frequency of 50 Hz. And the other important thing is the vector connection. You can see the vector connection is given here. It is DY11. Normally all distribution transformers, D stands for that the ST side is connected in delta, the primary side is connected in star, with the secondary side leading the primary side by an angle of 30 degrees. That is known as DY11. And you can see that there are tappings. There is a tapping given on the ST side, and this is the offload tap changer. So this has got 5 tappings, 1, 2, 3, 4, 5, and the nominal one is the third tapping. You can see the nominal voltage, that is 3. The switch position 3 is the nominal voltage rating, that is 33 kV, and 1 is plus 5%, 2 is plus 2.5%, then comes the 4, that is minus 2.5%, then 5, that is minus 5%. So you can, as per depending upon the ST voltage side, you can increase or decrease the voltage on the secondary of the transformer. Then the other most important thing, as the cooling is oil natural, air natural, these are the cooling fins which you can see over here. These are the cooling fins. As you know that the coefficient of cooling increases if you increase the area. So therefore this cooling fins acts as to increase the area, which are directly with the atmosphere. So once the oil gets heated up, it goes up, and when it goes up through this pipe, it comes to this cooling fins, where with the natural air it gets cooled down, and again it goes from this pipe it goes again back to the transformer. So this is a natural convection which is taking place in the transformer, and the cooling takes place with that. There is a transformer oil which we use in the transformer tank, and you can see that the weight of that it is given somewhere here. The weight of the transformer, the weight of oil is 585 kg, and the total weight of the transformer including this oil is 2.5 tons. You can see over. Then the other important thing is that is the conservator tank. This is the conservator tank. The top is the conservator tank. You can see the top one is the conservator tank, and you can see the level of the oil. There is a gauge which is given over here. You can see that the level of oil which is filled in the transformer tank. Normally, the conservator the oil should be filled till the half mark, and when it goes down, you have to add extra oil. You have to top up the oil in the transformer. So this is every time, as if you are an electrical engineer, during summer season you should come and check the level of oil in the conservator tank, and if it comes down, you have to take the necessary. You have to take this transformer for maintenance. You can see that through the conservator tank, it is actually connected through a small pipe, a GI pipe, to another device. This is known as the breather. What is the function of the breather? The function of the breather is just like our nose of the human being, to breathe in and breathe out. So whenever the transformer oil expands, what will happen? The oil will increase in the oil level of oil will increase in the conservator tank, and therefore whatever extra the space, the air space is there, that will be breathed out, and whenever there is the normal working temperature, again it will breathe in. So this breather is made up of silica gels. Actually it is the chemical composition, it is known as cobalt chloride. It is bluish in color under normal condition, and once it breathes in, along with that the moisture content will be there along with the air, so therefore it color changes to pink in color. So once it becomes pink in color, you have to take it out, and then again you have to heat it up to 200 degrees centigrade, so that again the color changes back to bluish. So 1 or 2 times you can do it, but after that you have to again change the entire silica gel and replace it with the original one. So here there is an oil seal. There is an oil seal you can see at the bottom. So whenever the air breathes in, there will be suspended particles with the air. So suppose some dust and all these microfine particles will be there, that will get suspended in the oil. So therefore this acts as the oil seal. So therefore this is also an important part. Whenever you do the maintenance take, you remove this and see that whether the oil in this has been deteriorated or damaged. So replace that oil with the fresh one. Then comes the other important thing is this one is the pressure vent. This is the pressure vent. Due to the internal faults in the transformer, so there will be the oil will get heated up. There will be heavy pressure, just like your pressure cooker, and if it exceeds and if no protection is given, then through this pressure vent, the gas, it will break that glass. You can see that there is a glass at the top. It will break the glass, and whatever extra pressure is, it will come out from the transformer. Therefore, there will not be any exploding of the transformer. Otherwise, there are chances that if you don't take care of, and if the pressure inside due to internal faults will go up, then the transformer may explode. So therefore, this acts as the pressure pump, and it is slightly, you see that an angle slightly twisted. It is like that. When it is raining, no water should go inside. That is why it is slightly tilted like this. And then the other important thing you can see is that this is the propose relay, which you can see that. There is a propose relay which is connected here. It is between the conservator and the tank body. Between the conservator over there and the tank body, there is another device which is connected. That is the propose relay. So this propose relay acts as, this is a gas actuated relay. This acts as a protection for the transformer. Any internal fault within the transformer, it acts as a protection. Inside there are 2 mercury switches, and when the oil goes down, first it gives a warning to the operator who is sitting in the panel room, and if the operator doesn't take care of that warning signal which is given, there is another switch, and when the further heating up, the oil further goes down, the mercury switch, the second mercury switch acts, and it isolates the transformer from the HT supply. So this, and you can see that this pipe, this pipe which is connected, it is at an angle of 11 degree with the tank body. So this is an important because manufacturers, when manufacture this Bucos relay, they see that the angle of this pipe should be at an angle of 11 degree with the top face of the tank body. So this is a ground mounted transformer. You can normally you see two types of transformer near to home. That is the transformer which is mounted on the H pole rails. So that they are known as pole mounted transformer, and this particular transformer is a ground mounted transformer. And if you come to the HT side, as per the safety measures, the height of the HT bushing from the ground level, it should be 2.8 meters. So that even if I am standing here with a stick in my hand, it should not touch the HT wires on that. From the ground level to the HT top bushing, when you mount this transformer on this plate, the height should be at least 2.5 meters. As per the safety standard, it should be more than 2.5 meters. We are kept here at 2.8 meters. So one important feature of the transformer is that the LT side, when you come to the LT side, the neutral should be grounded. So we have grounded the neutral. It is gone to the earthing pit. So there are two important earthing is there. One is the neutral earthing, and the second is the body earth. The transformer body is earth. You can see that the transformer body is earth. Yes, this is the transformer body is earth. The transformer body is earth. It is earth to the tank body. So this is the two important. One is for the structure earthing, and the other is the neutral earthing. You can see that the neutral is earth. So these are the drain pipes to drain out the oil. In case if your oil deteriorates, then you have to do the filtration of the oil. So this is the drain pipe. So here it goes to the filtration machine, and once it gets filled up, and once the oil is get filtered through this tank, yes, the top one, you can see that the top is there. So from the bottom, it goes to the filtration, this one, filtration equipment. The oil gets filtered, and every 1 hour you have to take the breakdown test. And the breakdown test, it should indicate the oil should withstand a breakdown voltage of 40 kV for a gap of 1 gap. And once the oil is filtered through the filtration machine, back it goes to the top of the converter tank. There is another pipe connected to it. There again the oil enters the transformer tank body. Then there is another important thing what you have to see, that is the temperature gauge. You have got a temperature gauge where you can see the temperature of the oil. This is the temperature gauge, you can see it is connected here. It is connected here, where you can see the temperature of the oil. So the temperature of the oil should never exceed 90 degrees centigrade. So you can see there is a temperature gauge is provided. So you have to, as an engineer, you have to make a regular check whether the temperature of the oil is exceeding 80 degrees centigrade. If the temperature of the oil is 90 degrees centigrade, in all means it indicates that the temperature of the winding is more than 100 degrees centigrade. And if it exceeds that, then you have to give protection of the transformer. You have to protect the transformer from overheating. That also you have to take care of. Then you have got the lifting legs. When you transport the transformer, there are lifting legs which are provided. There you can see it over here. This is the lifting legs which is provided. This one, the lifting leg which is provided. So you can see that the lifting leg this is providing the power. So again I sum it up. For a transformer, you have got the conservative tank, you have got the breather, fine, you have got the pressure vent, you have got the cooling fins, because it is a oil natural, air natural, you have got the LP side terminal box, then the Buchoz relay, the cables, the LT cables, then the earthing, the nodal earthing you can see, then the most important one, the specification details of the transformer, the offload tap changer, the temperature gauge, and last the structure. So these are the 5 most important, the protection devices as well as the normal devices which is connected to the transformer for its proper function. Can you remove it this way? This is a typical earthing, you can see it. There are 2 types of earthing, mainly pipe earthing and plate earthing. So for substations we normally give the plate earthing. To the plate size is of 600 into 600 into 6 mm, a copper plate where the width and the length is 600 mm into 600 mm and the thickness is 6 mm, and you have to make a pit of whose height is 3 meter, and then you have to put this copper plate of 600 into 600 6 mm, and you have to fasten another copper strip. This is a copper strip, you can see. Copper strip, it has to come. It's an old one, I think we can. There's a copper strip which comes all the way to it, and here it is just the welding is done with this clamp, and it goes, and this pipe is given. Why this pipe is given? Because during summer season you have to pour this water, because moisture, you have to make this pit moist, because the substation earthing, the earth resistance should not be more than 1 ohm. So therefore, and once the first time you make it, along with this copper plate, you pour charcoal and salt to decrease the soil resistivity. You put the charcoal and the salt, and after that, in regular time, you have to pour water only. And if the earth resistance goes more than 1 ohm, so you have to moisten it by pouring water. Therefore, this pipe is given to pour water so that it goes down to the copper plate, which is at a depth of 3 meter from the ground level. So there will be 5 to 6 earthings in a substation. One is for the transformer neutral, one is for the transformer body, then comes for the structure of the substation, then comes for the lightning arrestor, which is an important part. The lightning arrestor is another protection for the transformer from the lightning surge that I cannot show you because it is the topmost part. So you have got an earthing for the lightning arrestor. You can see that a cylinder at the top. A cylinder, just like your insulator, you can see at the top. So that is the lightning arrestor. It is a station type lightning arrestor. It can withstand a current of 33 kiloampere to 33 kiloampere. It can pass to the station type lightning arrestor. It's a station type lightning arrestor. We have got the earthing for the this lightning arrestor. We have got earthing for the this one, the substation structures, and then you have got earthing for the EB switch. This is again an offload disconnector. So whenever you want to take your transformer in maintenance, you have to open this offload circuit breaker. This is known as air brake switch. This is not an on-load disconnector. This is an offload disconnector. That means first you have to switch off the load, then you open this air brake switch. So there will be 4 to 5 earthings in a typical substation. Thank you.